Chapter 1. Mars, a Museum of Alien Memory. Professor Chandra Wickramasinghe is a well-known astrobiologist and co-founder of the Buckingham Centre for Astrobiology. He spent years challenging the traditional ideas about how life began. A former colleague of Sir Fred Hoyle, Wickramasinghe strongly supports the idea of panspermia, the belief that life exists throughout the universe and spreads through space by things like comets, meteorites, and cosmic dust. He has often said that life definitely existed on Mars, and even believes astronauts may one day find what he calls a museum of alien fossils on the Red Planet, remains of ancient life, possibly from an intelligent species. "I think it's very likely that Mars was once a green, life-filled planet," he told reporters. "Then something happened that turned it into what it is now, almost completely dead." As bold as this claim sounds, it's backed up by science. Mars once had liquid water, a thicker atmosphere, and maybe even a magnetic field. Scientists generally agree that billions of years ago, Mars was more like Earth, possibly able to support simple life, and maybe even more complex forms. Wickramasinghe takes it a step further. While most scientists stop at the idea of microbes, he thinks Mars may have hosted intelligent life that was destroyed by unknown causes. His idea of a museum of alien fossils paints a vivid picture: an entire ancient ecosystem lying quietly beneath Mars's red dust, waiting to be discovered. This theory isn't new. In 1996, NASA scientists found what looked like fossilized microbes in a Martian meteorite named ALH84001. That sparked years of debate. More recently, scientists like Barry E. DiGregorio have argued that NASA's Curiosity and Perseverance rovers may have photographed structures resembling signs of past life, such as microbial mats or ancient bacteria formations. "The early Mars could have looked like Earth," Wickramasinghe said in a 2017 interview. "It might have had oceans and even forests. We could be looking at a second beginning for life." While many scientists are cautious and point to other possible explanations for the strange formations, Wickramasinghe remains confident. He believes Mars used to be much more Earth-like and then slowly died due to loss of its atmosphere and magnetic shield, likely caused by solar radiation and core cooling. In books like Diseases from Space, 1979, A Journey with Fred Hoyle, 2010, and Our Cosmic Ancestry in the Stars, 2019, Wickramasinghe argues that life is not rare or earthbound. It's part of a much bigger biological system that stretches across the universe. Mars, in his view, isn't a failed world. It's a frozen archive of cosmic life. As scientists gear up to bring Martian soil back to Earth, the idea that alien fossils may lie just beneath the surface isn't far-fetched anymore. It's a real possibility, one that could change our view of life, death, and consciousness in the universe. Chapter 2. Impact, Extinction, and the Ghosts of Martian Life. This could have happened after impact. With that simple sentence, Professor Wickramasinghe points to a massive event that might have wiped out life on Mars. He's talking about a huge asteroid or comet crash, something similar to what happened on Earth 66 million years ago, when the dinosaurs were wiped out by the Chicxulub impact. Mars's surface is covered in evidence of violent impacts. Giant craters like Hellas Planitia and Argyre Basin were formed during a time called the Late Heavy Bombardment, between 4.1 and 3.8 billion years ago. Scientists like Botka and Ivanov have shown that Mars was hit hard during this period, possibly hard enough to completely change its environment. If life ever existed on Mars, Wickramasinghe says, these impacts could have destroyed all of it. This idea fits into his larger belief system. According to panspermia, comets and asteroids can both bring life to a planet and wipe it out. In a 2004 paper with colleague Bill Napier, Wickramasinghe explained how cosmic collisions can spread life and end it on a massive scale. The comparison to Earth's own mass extinctions is clear. Our planet has seen 5 major wipeouts, several likely caused by impacts. Wickramasinghe sees the same possibility for Mars. It could have destroyed it, he says, just like it did on Earth. He goes even further, imagining a long period of repeated impacts, a drawn-out planetary disaster that left Mars dry, lifeless, and exposed. If Mars went through a long era of massive impacts, he says, then it would be a dead planet. This idea is backed by recent research. Mars no longer has a magnetic field, which once protected it from solar radiation. Its core cooled, and without a protective shield, solar winds stripped away its atmosphere. Missions like NASA's MAVEN and ESA's Mars Express have found clear signs of atmospheric loss and surface erosion. Still, Mars shares many features with Earth. It has giant volcanoes, canyons, seasonal weather, and a similar tilt, giving it seasons like ours. In fact, Mars's axial tilt is 25.2 degrees, while Earth's is 23.4 degrees. Because of these similarities, space agencies believe ancient Mars could have supported life. Scientists like Michael Carr and Robert Haberle have written about how early Mars had water and a climate suitable for microbes. But Wickramasinghe pushes further. He doesn't just believe in Martian microbes, he doesn't rule out intelligent life. It's possible Mars had intelligent life before Earth did, he says. If that's true, traces of it could still be buried under the surface. This idea, while speculative, isn't completely off the academic radar. Harvard astrophysicist Avi Loeb and Penn State's Jason T. Wright have talked about the idea of long-lost civilizations in our own solar system, ones that might have vanished without leaving obvious traces. Wickramasinghe imagines Mars as a world that once had intelligence, was destroyed by massive disasters, and now lies silent, waiting to be explored again. If he's right, Mars is more than a lifeless rock. It's a tomb of forgotten history. Chapter 3: Fossils, Bacteria, and the Prospect of a New Martian Civilization. I think astronauts will examine those fossils Barry DiGregorio has talked about. They'll take a closer look and decide whether they're artifacts or real. Here, Wickramasinghe is talking about DiGregorio's claim that NASA's Curiosity rover might have photographed signs of past life, specifically trace fossils, which are impressions left by living organisms rather than the organisms themselves. In 2018, DiGregorio said that some tube-like structures in the Martian rock looked like fossilized microbes or biological activity. NASA said they were just mineral formations, but DiGregorio pushed back, accusing the agency of brushing off important evidence. Wickramasinghe sided with DiGregorio, putting himself among the small group of scientists who think we might already have photographic proof of ancient Martian life, but aren't paying enough attention. Wickramasinghe also thinks living microbes still exist on Mars today, most likely underground, where it's warmer and shielded from radiation. He points to the detection of methane spikes by the Curiosity rover in 2015. Some scientists think these could be signs of active biology. Wickramasinghe is even optimistic about the idea of terraforming Mars. He believes the red planet could be made habitable again, and not just in theory. They'll find bacteria there, he says, and I think we could make Mars a living planet again. Most scientists are more cautious. A 2018 study by Jakosky and Edwards said Mars doesn't have enough carbon dioxide to warm it up through greenhouse gases. That makes full terraforming very hard with current technology. Still, Wickramasinghe believes it's possible. You could build houses and eventually a civilization on Mars. I don't think that's impossible. This belief lines up with the goals of SpaceX and Elon Musk, who wants to build a human settlement on Mars. NASA also has long-term plans for sending people there. Musk has even said he wants to die on Mars, just not on impact. In 2023, Musk predicted that humans could land on Mars within 4 to 6 years, with a permanent outpost by 2043. Others, like Mars Society's Robert Zubrin, say it's possible, but not as fast or easy as building cars. Wickramasinghe sees this effort as more than engineering. He sees it as rediscovery, a chance to bring life back to a planet that once had it. To him, Mars is a kind of sibling to Earth, not just scientifically, but spiritually. He has also said, it's speculation, sure, but Mars might have had beings as intelligent as us, or even more. In other words, he's open to the idea that an intelligent Martian civilization may have once existed and was wiped out, and most of the evidence possibly destroyed. Wind erosion, dust storms, radiation, and impacts may have erased nearly everything. As Wickramasinghe says, I think the evidence has been virtually stamped out of existence. So for him, Mars is both a graveyard and a blank slate, a place where life once bloomed, was destroyed, and may one day rise again. Chapter 4. The Viking Signal. Life detected or denied. We have unquestionably found microbial life on Mars. The strongest evidence was from the Viking landers in the 1970s. Professor Chandra Wickramasinghe, Astrobiology Review, 2020. In 1976, NASA's Viking 1 and 2 landers arrived on Mars, each carrying a special biology experiment designed by Gilbert V. Levin. The test was simple in concept. Add nutrients with radioactive tags to Martian soil and see if anything eats it. If microbes were alive in the soil, they would metabolize the food and release radioactive carbon dioxide gas, which could then be detected. Both landers got positive results. Gas was released. This suggested some kind of metabolism had taken place. When the same test was done with sterilized soil, nothing happened. To Levin, this was proof. Mars had life. The data showed metabolism, he later said, but we rejected it because other instruments didn't confirm it. But NASA didn't agree. The Viking landers had 2 other biology experiments that didn't show signs of life. Even more importantly, the gas chromatograph mass spectrometer, GCMS, which searched for organic molecules in the soil, didn't find any. Since living things are made of organic compounds, NASA scientists said the positive result must have had a non-biological explanation, probably chemical reactions with things like superoxides or perchlorates in the Martian soil. By 1978, NASA officially declared the Viking results inconclusive. Instead of focusing on life detection, future missions turned their attention to geology and climate studies. Wickramasinghe sees this as a major failure. He says Levin, who he knew personally, originally announced to the press that NASA had found life on Mars, but the agency quickly walked it back. Levin made the announcement. Wickramasinghe says it was a step too far for NASA. They took it back. Although NASA never officially said, "We found life," Levin always believed the data showed exactly that. Until his death in 2021, at the age of 97, he stood by his conclusion and spent over 4 decades defending the experiment. In fact, the labeled release, LR experiment, was designed with clear criteria for detecting life, and it met every one of them. That's what Levin and co-researcher Patricia Strutt argued in Science in 1976. Wickramasinghe agrees. The LR experiment already fulfilled the requirements for life detection, but it was dismissed because the outcome didn't fit expectations. More recently, other scientists have revisited the Viking data. Researchers like Dirk Schulze-Makuch and Joop Houtkooper, 2007, proposed that Martian microbes, if they exist, could be much tougher and stranger than Earth microbes and might act in ways we don't fully understand. So maybe the Viking results were showing life, but we didn't interpret them correctly. Even so, NASA didn't reopen the life debate. The topic became tricky, not just scientifically, but politically. Announcing life on Mars based on unclear data could hurt public trust, future missions, and funding. To Wickramasinghe and Levin, however, that caution led to a historic mistake. They believed the Viking experiment revealed microbial life, and we ignored it. To them, the Martian soil was trying to tell us something back in 1976. We just weren't ready to listen. Chapter 5. Horizon Goal: Mars and the Future of Humanity. Mars remains our horizon goal for human exploration because it's one of the only other places where life may have existed. NASA Mars Exploration Program, 2023. This quote from NASA's official Mars website captures how important Mars is for human space travel. It's not just about rockets or robots. Mars represents one of the big questions. Are we alone? NASA sees Mars as a horizon goal, meaning it's the next big step after the Moon. The red planet is important for several reasons. It's similar to early Earth, has signs of past water, and shows seasonal changes in gases like methane, which might come from microbes or underground chemical activity. What we learn about Mars, NASA says, could teach us about Earth's history and help us find out if life exists elsewhere. Mars gives scientists a kind of natural laboratory. It helps us understand why Earth stayed habitable and why Mars didn't. If life began on Mars but died out, that tells us something huge. Life can start easily, but it's fragile. And if Mars still has life today, buried underground, that means life might be common in the universe. Mars as a testing ground for the cosmos. Like the Moon, Mars is a rich destination for scientific discovery and helps us test technologies for deeper space. NASA Strategic Plan, 2022. NASA doesn't just see Mars as a science target. It's a proving ground, a place to test out the tools we'll need to go even farther. To explore space for real, we need to solve problems like radiation protection, water recycling, local fuel production, and long-term habitats. One important step was already taken. The Perseverance rover carried an instrument called MOXIE, which successfully made oxygen from the thin Martian atmosphere. This is a big deal. Oxygen is needed for breathing and fuel, and this shows we might be able to live off the land. Future tech for Mars will include building habitats using Martian soil, regolith, making fuel, like methane, using local CO2, creating closed-loop life support systems, safely landing large spacecraft, supporting human mental and physical health on long missions. NASA's Artemis program sees the Moon as a training ground for Mars. Lunar missions will test systems in space before trying them on Mars. That includes the Lunar Gateway, Starship landers, and future Moon bases. The NASA Office of Technology Policy says that tech developed for Mars will also help us reach farther, to icy moons like Europa, or even exoplanets someday. In other words, Mars is the beginning, not the end. A planet that reflects our own. To Professor Wickramasinghe, Mars isn't just a science target. It's a mirror of Earth's early history, and maybe its future. He often speaks of Mars as a planet that once bloomed with life, suffered disaster, and now lies in silence. Terraforming Mars, he says, could give us a backup for civilization, but it might also bring life back to a world that once had it. This is similar to NASA's goals, but Wickramasinghe goes further. He doesn't just want to study Mars, he wants to restore it. Whether by seeding it with microbes, building habitats, or even reconstructing its ecosystem, he sees Mars as a place of potential rebirth. He also supports efforts by Elon Musk and NASA to settle Mars, not just for survival, but because he believes we belong among the stars. In his view, Mars isn't just a dead rock. It's a lost world that deserves another chance. And maybe, just maybe, bringing life to Mars will reconnect us with the life it once had.